Welcome back, students. We're going to talk about buffers and indicators. So in the last lesson, I introduced you briefly to indicators. Here is an indicator off of our indicator chart on page 10. So the indicator is bromothymol blue. All indicators are weak acids. So they have this big long formula. In this case, we call it BB. That's not an element. Those aren't elements off the chart, but we just shorten that part of the molecule and we just call it BB, but we put an H on it. So it's HBB, and its range is 6.0 on the low end. Its pH range is 6.0 to 7.6. From 6.0 and down, it's yellow. And on the other end of things, that's the conjugate base of HBB, which is BB negative after it's thrown away its proton. From 7.6 up, it's blue. Okay, so what I'm trying to say is if I have a pH scale, this thing's range is 6.0 to 7.6. From 6.0 down, it's yellow, and from 7.6 up, it's blue. Right in the middle, it'd be green-ish, okay? And HBB is the color of HBB itself, that substance is yellow, and the color of BB negative is blue. So I'll have that make more sense here in just a sec. So here's a reaction. I take my weak acid, my indicator HBB, I drop it in water, I make BB negative and H3O. HBB is the yellow substance, BB negative, that entity is the blue substance. They are all in the drop. Everything in that reaction is in the drop. Now, when I take, and that drop is a giant drop of indicator, right? But you have to imagine it really small. I'll show it to you in a sec. But you imagine that indicator, let's say it's shifted to the blue side right now. So it's like having yellow paint and blue paint mixed together, but I have a whole bunch of blue paint and just a little bit of yellow paint. The whole thing looks blue. So this drop is blue right now, and all of those entities are in the drop. Now the drop hits hydrochloric acid. Think of it as this drop hitting an ocean of H3O positive. Now Le Chatelier's principle tells us exactly what happens. What happens to the concentration of H3O positive in the drop? Well, it goes up because it just hit an ocean of H3O positive. It goes up, so therefore we shift away, up, up, down, down. So yellow paint is going up and blue paint is going down. So the drop turns yellow, which makes the rest of the acid turn yellow. So it looks something like this. Drop hits, turns yellow, and everything turns yellow, okay, as it diffuses. Okay, same thing if we had, if we were hitting an ocean of base. The drop comes in, hits this ocean of base. A side reaction happens between the strongest acid, hydronium, strongest base, and we make water. What that's doing, and the water that it makes won't affect the concentration of water in the reaction because the water is 55.5 moles per liter. That's so massive. It's like how much water would you need to have to change the concentration of water? Because water is water. Anyway, what really happens is H3O positive goes down because OH is like gobbling it up, right? So the concentration of that goes down. It shifts that way. Blue paint goes up, yellow paint goes down, so the drop stays blue. So when it hits, blue remains, turns blue. Okay, so that's how an indicator works. It's a weak acid dropped in water, has two entities. One is one color, the other entity is a different color, and has a pH range. Okay, a buffer. What's a buffer? It's a solution made up of relatively large amounts of weak acid and its conjugate weak ion, the purpose of which is to maintain a relatively constant pH when small amounts of acid or base are added. So, take this buffer in the human body. So I've got my H2CO3 buffer, my hydrogen carbonate buffer. So, let's say our blood starts turning more acidic. Maybe we're hyperventilating. If the acid goes up in our blood, Le Chatalier will shift to try to bring the acid back down. Okay? And that's what a buffer does. A buffer has an acid, a weak acid, and its negative ion. So it doesn't matter if it's acid that's present or base, it can shift either way. So here's the base operating. Or sorry, this is a different buffer, but let's say acid comes in. And let's say my strongest, this is not using Le Chatelier's at the moment. This is just looking at the chart for strongest acid, strongest base. Bronsted-Lowry. So there's my strongest acid. There's my strongest base. So if acid starts piling up, that base starts gobbling up those acids like this. H3O will get gobbled up or transfer a proton to HPO42 negative. And as acid builds up, it gets converted to water and H2PO4 negative. Same thing if base shows up here. If base comes in, now my strongest acid is H2PO4 negative. My strongest base is that. Same thing. Instead of OH piling up, it starts reacting with the H2PO4 negative. So that's the point of a buffer. The weak acid can gobble up the hydroxides, or the base form can gobble up hydronium and maintain a relatively constant pH. So there's my beaker. You can see I've got H2CO3 in there and HCO3 negative. A buffer is a weak acid and its negative ion. Okay, that's it. All right, we are almost ready for a unit test.